You try it 45 is asking us to simplify each of the following. And we're looking at this over the complex number system. It doesn't say just to find the real numbers. Square root of negative 100 doesn't have a real solution, but it does have a solution. I can simplify this to the square root of negative 1 times 100. The square root of negative 1, remember, we can define as I. So this is going to be I times the square root of 100, and the square root of 100 is a perfect square. That's just the number 10. So it's I times 10, or 10I. Similarly, for letter C, the square root of negative 16. That's the square root of negative 1 times 16. The square root of negative 1 times the square root of 16 is I, and the square root of 16 is 4. I times 4, or 4I. For letter B and D, we can go ahead and simplify the square root of negative 200 as the square root of negative 1 times 200. Square root of negative 1 is I. Square root of 200, though, isn't a perfect square, so we are going to have to simplify that a little further. I square root of 200, we're going to break that down using our factor tree. 2 times 100. 100 is 10 times 10. Now, although 10s aren't prime numbers, we do have a pair of them. And we're going to go back to anytime I can circle a pair, that number in that pair comes out from under the radical. So it's I times 10, and then what's left under the radical is the number that didn't get paired up. Now, if there was more than one number that didn't get paired up, it too would go under the radical, and we'd just be multiplying it all together. So in this case, I have 10I square root 2. All right. Negative 12, square root of negative 12, rather, is the square root of negative 1 times 12. Square root of negative 1, we're going to call, again, I. Square root 12. 12 we're going to break down. So 2 times 6. 6 breaks up into 2 times 3. And anywhere we can find a pair at the end of a branch, that number is going to come out from under the radical. So it's I times 2, and then the number that didn't get paired up stays under. So I2 radical 3, or I like to write it as 2I times radical 3. It's all multiplied out there. So the purpose for simplifying these is so that when I end up with a quadratic that has a number that's negative under the radical, or my discriminant is negative, I can still simplify that answer. And that's what we're going to see in these next few examples here. Solve for x, simplify your final answers completely. So for letter A, 3x squared minus x equals negative 2, I first need to set it equal to 0 before I can use the quadratic formula on it. So I have 3x squared minus x plus 2 equals 0. Identify A is 3, B is negative 1, C is 2. Then use the quadratic formula. X equals opposite of negative 1, so negative 1, plus or minus the square root of. I like to compute the discriminant off to the side and then just stick it under the radical. So the discriminant is b squared. Notice I put the negative 1 in parentheses and squared it, minus 4 times a times c. 4 times 3 times 2. So I have positive 1 minus 24, which is a negative 23. That's my discriminant that's going under the radical symbol in my quadratic formula. And then divided by 2 times a, 2 times 3 is 6. So I have x equals positive 1, because the two negatives make a positive, plus or minus the square root of negative 23, that's negative 1 times 23, divided by 6. We already know that the square root of negative 1 can be renamed I. The square root of 23 will leave under the radical. That's prime. We wouldn't be able to break that down any further. So my two answers, and oftentimes they'll ask you to write this up on WebAssign this way, is 1 plus I square root 23 divided by 6, or 1 minus I square root 23 divided by 6. Make sure that division bar goes all the way across and is underneath everything up in that numerator. Right, for letter B, solve for x. And again, we're looking for any solution, not just a real solution, but any solution. So in this problem, my A is negative 1, my B is negative 6, my C is negative 10. All right, and while I'm at it, I might as well compute my B squared. Negative 6, the quantity squared, minus 4 times A times C. Let's just figure that out. And again, don't be afraid to use the calculator. Watch your signs, watch your parentheses. Negative 6, the quantity squared, minus 4 times, and again, in parentheses, negative 1 times, in parentheses, negative 10. All right, I come up with negative 4 for my discriminant. So it's x equals opposite of negative 6, which is going to be a positive 6, plus or minus the square root of my discriminant is negative 4 over 2 times a, 2 times negative 1, or negative 2. So 6 plus or minus negative 1 times 4 under the radical symbol divided by negative 2. 6 plus or minus, the square root of negative 1 is I, square root of 4 divided by negative 2. But the square root of 4, I can simplify that. Square root of 4 is just 2. No longer under the radical. So this is 6 plus or minus I2, or 2I, divided by negative 2. All right, let's split this up and simplify it. It's 6 plus 2I divided by negative 2. That's negative 3. 6 divided by negative 2 is negative 3, plus positive 2I divided by negative 2I is negative 1I. All right, let's break up the other one here. 6 minus 2I divided by negative 2. So 6 divided by negative 2 is negative 3. Negative 2 divided by negative 2 is positive 1I. When you split this up, you're splitting the fraction up like this. Negative, or 6 divided by negative 2 minus 2I divided by negative 2. And then reducing each fraction down individually. Okay. All right, letter C, we have our A is 1, our B is 3, our C is 3. In fact, this is one that we did earlier when we were graphing the quadratic. So B squared minus 4AC, that's 3 squared minus 4 times a times c. We saw this to be the number negative 3. So our x equals opposite of b, so negative 3 plus or minus the square root of negative 3. That's my discriminant. Divided by 2 times a. 2 times 1 is 2. In simplifying this, it's going to be negative 3 plus or minus the square root of negative 1 times 3 divided by 2. And again, the square root of negative 1 is I. The square root of 3, well, 3 is prime. We can't do much with that. So our final answer is going to be negative 3 plus or minus I radical 3 over 2. If I have to separate it up into two separate answers, we'll see negative 3 plus I radical 3 divided by 2, or negative 3 minus I radical 3 divided by 2. Often on WebAssign, they'll ask you to write it as two separate answers separated by a comma. And that's what it would look like on WebAssign. For the last one, we're going to be using our calculator here because we've got a decimal, and so we can expect a decimal answer out here. So let's go through this. A is negative 16, because it's negative 16x squared, plus 40x, so my b is 40, plus 1.5, so my c is my constant, 1.5. b squared, the quantity negative 16 squared, minus 4 times a, oops, messed that up, that should be 40 squared, b squared, 40 squared minus 4 times a, which is negative 16, times c, which is 1.5. All right, so let's see what that turns out to be here. So I have 40 squared minus 4 times negative 16 times 1.5. This goes back to a word problem that we did earlier in finding an intercept. So I've got, what, 1696. All right, I believe it was the golf ball one that we talked about earlier in this homework set. So let's go ahead and figure out what we've got here. X equals opposite of b, negative 40, plus or minus the square root of 1696 divided by 2 times negative 16, or negative 32. Because this is a story problem, or was referring to a story problem back a while ago, we're going to go ahead and look at the decimal approximations to this. So we have a negative 40 plus the square root of 1696 divided by negative 32. And then we're going to have negative 40 minus the square root of 1696 divided by negative 32. All right, we're going to look at the decimal approximations to these because on the word problem, they were wondering, how much time would it take for the ball to land? So we're going to look at the first one, negative 40 plus the square root, so second x squared, 1696, close parenthesis. Now hit the enter button to calculate the numerator, then divide by negative 32. So a negative 0.037. All right, which in terms of the word problem isn't going to work because our answer was in seconds, I believe. But let's take a look at the next one here. And we're going to do negative 40 minus that same square root of 1696, close parenthesis, figure that amount out, and then leave that amount and divide it by the negative 32. Don't round. We come up with 2.54. And again, if we're taking a look at, something launching off and then landing on the ground, what that would mean would be it took about 2.54 seconds for it to land on the ground. All right, so those would be our two answers to this equation.